everyone, this is Dr. Esperanza and welcome to my calculus class. And for today we're going to be working on the derivative rules and how to use the derivative rules correctly. So we're going to be seeing the power rule, we're going to see the quotient rule and the trig functions and how to find its derivative in today's workshop. And today is going to be a little bit special because you're going to be sitting in my classroom with my student here in Barstow Community College. So stick around and let's learn the derivative rules. Now, you need to remember that derivative rules are just shortcuts. To be able to find the derivative of any function, the limit formula always works for any function. No matter what the size is, no matter what it looks like, no matter if it's trig function or a polynomial function or a radical function, the limit equation works. Now, if we're going to be solving this particular limit, just to review, how are we going to solve for the limit of square root of 2x plus 3 as x approaches 0? Tell me. It's just what? As simple as substituting the values of x to the function. So without even using the calculator, we can solve this, right? So what is the limit of this function? So the limit exists. So every time you have a numerical value for your limit, as long as the denominator is not equal to 0, because that is the only or the easiest reason that we could find when the limit does not exist analytically. So this one exists because we have a value of y. And again, every time we look for the limit, don't get too intimidated with the notation and how it's written. It's basically just, let's say this is f of x, and this is the value of x. We are simply finding the value of y of that function. That's basically what the limit is. But the added definition is that your value of y coming from here and coming from here. That's the only additional information that you need to think about when you see this. But theoretically, you're just finding the value of y in any function. So sometimes it's easy, sometimes it can be a little bit challenging. This one is a rational function. A rational function is just a fancy way of saying fractions with polynomial. So if we're going to find the limit of the function for this one, what will be your limit? Does this exist?
No.
Why not?
Because
the denominator will turn to 0. Because if this will be 0 and this will be 0, so you have 0 plus 1 all over 0, and we have 1 all over 0, and we know that every time you have a denominator of 0, that's an indicator that your limit does not exist. So this one, the limit does not exist because of the denominator of 0. And when we see it in a graph, perhaps at x equal to 0, the asymptote is at x equal to 0, or that is the point of discontinuity on a given rational function. So that is just an indicator. We don't know for sure because we're not seeing the graph yet, but mathematically, that is why we're getting a 0 denominator. How about this? X squared minus 4 all over x minus 2. If we direct substitute 2 to x, what will happen to your rational function? It will turn into 0 if we use direct substitution, because this becomes 0, this will turn into 2, this will turn into 2, and 2 minus 2 is equal to
0.
And this one will become
0.
So what type of or special type of rational function is this? We tackled this 2 weeks ago. There is a special term we use for 0 over 0 in mathematics. We call it indeterminate. Now, again, math is a foreign language and you need to know all the words that we use for those descriptor, because a number all over 0 is undefined, right? 0 all over a number is a real number, it's equal to 0. But a 0 all over 0 is a special case of rational function that all of you should be aware of. We know it does not exist because the denominator is 0, but it is a special rational expression that we call this. Why do we need to know that? Later on, I will teach you or show you the importance of knowing an indeterminate rational function in answering more calculus problems. Okay? So this one is indeterminate and it does not exist. And what if we factor. Because we know that substitution is just one way of solving for x. That is our first line of defense. But can we still modify this and change how it looks like and see if it will exist? Okay. Is this a factorable numerator?
Yes.
What is the factor of x squared minus 4?
X plus 2 and x minus 2.
And by doing that, we are not changing the value of the function. We are just modifying the look of the function. And why do we need to modify it? Because by doing so, we can eliminate the common term, and now we are left with the limit of x plus 2 as x approaches 2. And now, by solving the limit with a new, not new, I don't want to say new, modified function, does it exist?
Yes.
Yes, because now it's 2 plus 2, which is equal to 4. So be careful. Again, in calculus, the reason why it's called analytical math is because you need to think first before you can conclude that your answer is this. Because sometimes doing everything procedurally, like step 1, step 2, step 3 in calculus, it's not going to work. You need to make sure that you know what you're doing and you know why you're doing it. So now we know that this exists by factoring. So if we graph this, probably or possibly, at x equal to 2, it is a point of discontinuity or a circle. All right? Possibly. So we can check that later on. How about this one? If we solve this, what would be the value of the limit by solving it? Is this a factorable numerator?
Yeah.
Yes. So let's factor it. What's the factor of the numerator?
X plus 4, x plus 3.
And that is the factored form of the numerator. And we don't need to factor this, right? And by doing so, what happens?
X plus 4 cancels 4.
So we now have the limit of x plus 3 as x approaches negative 4, which is negative 1, right? But with direct substitution, will that exist? No, because the denominator will turn into 0 right away, right? So, again, think before you decide what method you're going to be using. Solve this. You have the value of the limit? Does it exist? Yes or no? Yes. Where does it exist? At x approaches 0. Y is
1/2.
1/2. And what method did you use? Substitution or factoring? Now, just like what I mentioned, whenever you're solving any calculus problem, you always need to make sure that you know the basic. And the basic is the first line of defense is substitution. We can factor this because they're factorable. However, at x equal to 0, 0, 0, 0, without going through the process, I know that it's still 1/2. However, you factored it out, it's still going to be the correct answer. Because this is what I want you to think every time you're working on any problem in calculus. Because this is what you will encounter today when we start working with derivatives. Derivative rules, I know that this is not your first rodeo. You've seen the derivative rules before. And we have so many derivative rules, right? Not all of them. I mean, if you know your functions really well, if you choose the right rule, finding the derivative of a function will be so fast, so easy, so seamless. But if you choose the wrong rule, you will end up with a long method. Not saying that it will be wrong, but it's going to be a process. Just like what happened in this problem. Some of you factored it out, did those processes, and yet, if you substitute it and use this, you'll be able to answer it as quickly as possible, right? So keep that in mind because this is what you will experience in our workshop today. Again, the derivative rules, the reason why it's called rules, it's because it's just a shortcut in finding or using this formula in finding f prime of x. And we read that as f prime of x because that is your derivative of f of x. Also known as the formula that you can generate to produce the equation of the slope of any function on x. So if this is your f of x, this little graph right here, if you have a point right here, and you need to find the equation of the tangent line of this point at the value of x, you'll be able to solve it using this formula with just a single point, because it will give you the equation of the slope. Got it? So that is what you need to remember about f prime of x. One of its many important uses, equation of the slope of an f of x at any values of x. Okay? And we call it f prime of x, or this symbol. Now, calculus can be extremely intimidating for most students because there's so many symbols in calculus. One of them is this, because when I was starting doing calculus problems, I don't know when, it's difficult for me because there's so many symbols and I don't know how to use them. My teacher's just giving me the formula, and the teacher will tell me, okay, just use the formula and find the derivative, and that's what I do. I just use the formula without understanding what it means. And when I fully understood what calculus is all about, learning calculus will be a lot easier if you're understanding the symbol. So let's understand the symbol. This symbol is a command. It's a command that is basically asking you to take the derivative of the function. That's basically what it is. It's a command that's telling you to take the derivative of f of x. But instead of writing it in words, we write it in symbol. And we can just write like that, because it's too plain and simple, or it's too vague. So writing it out with a symbol like so will help us identify what we need to do or work on in that math problem. All right? So you will see this notation in all our derivative function from now on. Okay? So why do you need to know this? Because once you work on implicit differentiation, partial derivatives, differential equations, all those complicated derivative rules will be more complicated because of those symbols. So as early as now, you need to make sure that you are acquainted with this symbol. So that's what we're going to be doing today. Derivative tip. Your first line of defense when you're working with derivative is the power rule. When we are working on limit, your first line of defense is substitution. If substitution is not working, use another technique. In derivative, power rule. Do you still remember what power rule is? Good. So if I'm going to take the derivative of x to the n, the derivative of x to the n according to the power rule is bring down n and subtract 1 from the exponent. And that is your power rule. So if I have 4x to the 5th, to find its ddx, or derivative of that, we're going to bring down the exponent and subtract 1 from it. And this is your power rule, which is equal to
20x to the 4th.
20x to the 4th. And that is your power rule. Now, how do you know that you're going to be using the power rule? There needs to be an exponent. That's why it's called a power rule. So when there's an exponent, we can use this. All right. Law of exponents. As I mentioned last week, you need to know your law of exponents, especially maybe this rule right here, because you will see this a lot when you're working with derivative of a function. And when you are working with the derivative of a function and you don't know how to change your function into an exponential expression or equation, it will be difficult to take its derivative or use the derivative rules. So make sure you know your law of exponents. Do you know your law of exponents now? I hope so. And aside from the law of exponent, you need to know your factoring technique. Because sometimes you need to modify the function so that it would work for you. Because sometimes it's like playing a Rubik cube. Sometimes you need to use a certain technique for you to be able to complete the squares. It's basically similar to this one. If you know your factoring technique, you'll be able to modify more functions that would make it a lot easier for you to work on. So law of exponents, factoring, what else do you need to know? Or math fundamentals that you need to know in calculus? No, not know, but master what? Fraction. As silly as it is, most of my calculus students are still having trouble adding, subtracting, multiplying, dividing, and simplifying fractions. And you've seen this before from our examples last week. So know your fractions. And if you don't know your fractions, I have this video with the Aaron Sanchez who will help you master your fractions. And if you need to know more about the derivative rules, just click on this button right here and I have more examples on how to use those derivative rules that we're working on today. So, 3 basic math fundamentals that you need to have mastered so that calculus will not be too frustrating. You can still learn it, but it will be frustrating if you haven't mastered it. Law of exponents, factoring, fractions. Alright, so let's see this. This is what I'm talking about. When you see a formula in calculus, it looks Chinese to me. It's weird because we don't normally use it. But we're going to be using them and making sure that you're understanding every little apostrophe, every little parentheses, and every little G and F in your function. We're using this, maybe this, today. Next, first rule that we're going to be using today is the rule for e to the u du. Now, as I've mentioned, knowing your formula and knowing how to read it is important because this will help you understand how to use the derivative rules. So we have to find the derivative, because it's a command, take the derivative of the function e to the 2x. And according to the derivative rule, to take the derivative of e to the u, its derivative is equal to e to the u times du. So let's understand and make sure that we know these symbols. U can be a function, can be a numerical value, can be a fraction, can be a trig function. That is your f of x, whatever is given in your problem. Du is your derivative of f of x. That's basically what it means. So when you know your symbols and when you know how to produce them, finding its derivative will be as simple as this. So here's how we're going to use this technique. According to the formula, the derivative of e to the u is e to the u du. And this is kind of looking like e to the u, right? So let's write down the formula and finding the ddx of e to the u. It's e to the u times du. Now, all we need to do after that is to find this and find this, so we'll be able to find the derivative of that. So how are we going to do that? Let's do it step by step first. If I have, or if I need the u, what will be u in this problem? 2x. E to the u, e to the u is 2x, right? Now, we found our u. How are we going to find the du? According to the definition, the du is the derivative of f of x, right? Do you know the derivative of 2x? 2. So now we have the du, now we have the u. All we need to do is to replace this and this with that, and we're finished. That is the derivative of e to the 2x. It's going to be e to the 2x times 2. That's it. This is your f prime of x. But if you want to simplify it and write it in standard form, the standard form of this function can be written as 2e to the 2x. This is the standard form of your function. However, know that this is already a valid derivative function. Got it? So you just need to make it pretty. And making it pretty is writing it in standard form. So that is your f prime of x, 2e to the 2x. Every time you are finding the ddx of e to the f of x, write down what formula you need to produce. E to the u du. After that, write down what u is, and u is 2x in your problem, and du is your derivative of 2x, and you can do that in your head, right? Which is 2. And plug it in. This will turn into 2x, and this will turn into 2. So now you have e to the 2x times 2, and that is your derivative. But if you want to make it pretty, that is your derivative on your own. See if you can follow what I have instructed you to do. And again, this is Dr. Esperanza, and thank you for spending your time with me learning calculus. And if you happen to like this video, please like, share, and subscribe to my channel. And if you happen to know anyone who is struggling in mathematics, please share this and tell them that they can watch my videos from algebra all the way to college level calculus in my YouTube channel. Thank you, and see you again next time. Bye! The method that I asked you to work on, and see how simple answering this problem is.